Okay, hi everyone. Here are the captures I did on 101 for the circuit breaker popping for the turn signals. And to be honest, it took a bit to get this thing to act up. I think I did like, a total of 12 captures. But once I got it hot and got it to act up, then the problem was very repeatable. And then I was able to isolate the issue. So here's one of the first ones where I saw the current act up. If you notice here, when the flasher is like going on, off, I have 52 amps. And the breaker is it's a 25 amp breaker, okay? But the thing is, with the flasher circuit, okay, it's not full steady current all the time. So until it starts to get like really hot, then the breaker potentially will pop. And that's what was so intermittent and troublesome about this problem. So if you didn't have a scope to find this issue, it would be very difficult, because with a regular amp meter, amp clamp, whatever you have, it only averages the current, okay? And then when it does mess up, chances of you finding that problem are very minimal, okay? You can get lucky, don't get me wrong, but your chances go way down, okay? So anyway, this is when I first saw it to act up. I've got 52 amps peak. And then the next one that I did, I was seeing how long it would take to trigger the circuit breaker. So on this capture here, when the breaker finally popped, it took 1 minute and 9 seconds finally for it to pop that circuit breaker. Okay, so then after that, then I'm thinking to myself, okay, so is it only on the left side? Is it on both sides? What's going on? So I thought to myself, well, to figure out what side the issue is in for the excessive current, I looked at the wiring schematic and the way the modules are wired. One side gets a signal, for the left flashers, and another signal wire gets the signal for the right flashers on the wiring schematic off of the modules for the main module and the auxiliary module. So what I did was, after here pressing on the left turn signal foot switch and having the excessive current of almost 50 amps, I then pushed on the right foot switch and the current went way down. Okay, so the steady state on here is about 2.5 amps, and then peaks at about 10. So right here to the right turn signal current, that is normal, okay? So I just isolated which side the fault was in very easily using current and a scope, okay? So now, after seeing that, I started thinking to myself, okay, so where on the left side it is. So I started disconnecting wires. I started at the back for the back left turn signals. The current didn't change. And then when I got to a terminal board in the side console and I took off the wire DS21B at the XSC8 number 5 junction, the current went down. So here, if you notice, when I have the excessive current with that wire on that terminal, well, then when I take the wire off with the left turn signal on, the current goes back to normal. And I did it a couple times just to show, what I was doing here, okay? So this proves that the short is in that circuit exactly. So I just pinpointed the problem using the current clamp and the scope, and it was actually very easy once I started to get it to act up, and then I was able to figure out, you know, where the actual fault in the wire is. You know, what circuit, what branch, where do you have to go. That's you know, half the battle is knowing which way to go when you're diagnosing a short to ground. It can be a real pain in the butt. Believe me, I know. Alright, so now I found that wire, and I showed that in the other video. Actually, I'll show that the next video will be showing that shorted wire to ground. Okay, and it'll be in the third part. I'll show that, but then I repaired the wiring, and then this is what I have now, steady state. So now I only have 7.245 amps. And this was just with the left turn signal on. We'll just zoom in a little bit more. So the peak's 7.6, but then steady state's about, probably about right there. Probably about, 2.4 amps. Okay, so that's what you should have, you know, for this vehicle, for the current on the turn signals. You shouldn't have too much, because all the turn signals on this bus are LED, so they don't draw a lot of current. So then, after I did that, then I'm going to show, I let it run for just a little bit longer. Let's see, this one here. But on this one, what I did was I cycled the turn signals, because I wanted to see what the current looked like, you know, for the left foot switch, the hazard foot switch, the right, and then the actual hazard switch on the side console dash, and that should be the same. Okay, so like I said before, this part of current here, that's my left turn signal. This portion here is my hazard foot switch. This portion here is my my right turn signal foot switch. And then from here to here is the hazard switch on the side console. Okay, so, and like I said, the current is a lot lower now. I have, let's see, what do I have? Yeah, about 3.7. It's about the same on the right foot switch too, maybe just a tad bit higher. And then the hazards are about the same. The hazards, you know, that's with all your turn signals on. Yeah, I've got about 4.6 amps. So this was the last one that I did, you know, just looking at the current again, and then I had also let it run with the turn signals on again for like over a minute plus, just to make sure everything was hot and there was nothing else wrong with the system. But that's what the problem was, and this is how I found it, using current as a diag tool, and using it to help you isolate shorts to ground, especially with a scope. It's very handy, beneficial. It'll help you fix things right the first time and not wonder if you got that short to ground. Okay, especially with pulse width modulated circuits, flasher circuits, you really need to have a scope to find these short to ground problems, because if you don't, not saying that you can't fix it, but it'll take you more time and it will be more tedious. So I thought this would just be another good example for everyone on how important you need to have excuse me, you need to have a scope, just period. You have to have one. So Anyway, that's it. Hope everyone enjoyed that, and everyone have a good afternoon. Thank you for watching.